Good afternoon. This is Software Architecture Design presented to you by Edgar Wright and John A. Brown. So let's talk about the common architectural design. Architectural styles that can be organized by their key focus areas are message bus, which prescribes the use of a software system that can receive and send messages using one or more communication channels. Service-oriented architecture, which defines the applications and that expose and consume functionality as a service using contracts and messages. Client-server, which separates the system into two applications where the client makes requests to the server. Three-tier or N-tier separates the functionality into separate segments, which each segment being a tier located on a physically separate computer. Domain-driven design is focused on modeling a business domain and defining business objects based on entities with the business domain. Then there's component-based, which is to break down the application design into reusable, functional, or logical components that expose well-defined communication interfaces. Layered, which divides the concerns of the application into stacked groups or layers. And then finally, there's object-oriented, based on the division of responsibilities of an application or system into objects, each containing the data and the behavior relevant to the object. Let's look at some types of architecture. There's the business architecture, which defines the strategy of business, governance, organization, and key business processes within an enterprise and focuses on the analysis and design of business processes. Then there's the application software architecture, which serves as the blueprint for individual application systems, their interactions, and their relationships to the business processes of the organization. There is information architecture, which defines the logical and physical data assets and data management resources. And then finally, information technology architecture, or IT architecture, and that defines the hardware and software building blocks that make up the overall information system of the organization. So let's look at the breakdown on this slide. The architecture design process focuses on the decompositions of a system into different components and their interactions to satisfy functional and non-functional requirements. So the key inputs to software architectural design are really the requirements produced by the analysis tasks, and the hardware architecture. The software architecture in turn provides requirements to the system architect who configures the hardware architecture.
This is the most crucial step because it affects the quality of the design that follows. Without a clear understanding of the problem, it is not possible to create an effective solution. In fact, many software products and projects are considered as unsuccessful because they did not actually solve a valid business problem or have a recognizable return on investment. Each quality attribute is given an estimate, so in order to gather quantitative measures or quantitative data, the design is evaluated. It involves evaluating the architecture for conformance to architecture quality attribute requirements. If all the estimated quality attributes are as per the required standard, the architecture design process is finished. If not, then the third phase of software architecture design is entered, architecture transformation. However, if the observed quality attribute does not meet its requirements, then a new design must be created. This step is performed after an evaluation of the architectural design. The architectural design must be changed until it completely satisfies the quality attribute requirements. It is concerned with selecting design solutions to improve the quality attributes while preserving the domain functionality. Further, a design is transformed by applying design operators, styles, or patterns. For transformation, take the existing design and apply design operator such as decomposition, replication, compression, abstraction, and resource sharing. Moreover, the design is again evaluated, and the same process is repeated multiple times if necessary, and even performed recursively. The transformations, i.e. quality attribute optimizing solutions, generally improve one or some quality attributes while they affect others negatively. This slide shows the key principles to be considered while designing an architecture. 1. Consider how the application may need to change over time to address new requirements and challenges and build in the flexibility to support this. 2. Use design tools, visualizations, model systems such as UML to capture requirements and design decisions. The impacts can also be analyzed. Do not formalize the model to the extent that it suppresses the capacity to iterate and adapt the design easily. 3. Efficient communication of the design, the decisions, and ongoing changes to the design is critical to good architecture. Use models, views, and other visualizations of the architecture to communicate and share the design efficiently with all the stakeholders. This enables rapid communication of changes to the design. Identify and understand key engineering decisions and areas where mistakes are most often made. Invest in getting key decisions right the first time to make the design more flexible and less likely to be broken by changes. 4. Start with baseline architecture and then evolve candidate architectures by repetitive testing to improve the architecture. Continue to add details to the design over multiple passes to get the big or right picture, and then focus on the details. Here are the key principles of software architecture design listed on this slide. I'm only going to describe a few at this time, which are highlighted in bold. First, minimize large design upfront if the requirements of an application are unclear. If there is a possibility of modifying requirements, then avoid making a large design for the whole system. Second, it specifies that functionality of the components should not be repeated, and hence a piece of code should be implemented in one component only. Duplication of functionality within a single application can make it difficult to implement changes, decrease clarity, and introduce potential inconsistencies. Third, understand how components will communicate with each other, which requires a complete knowledge of deployment scenarios and the production environment. Lastly, naming conventions should be defined in advance. They provide a consistent model that helps the user to understand the system easily. It is easier for team members to validate code written by others and hence will increase the maintainability. Software architecture is often described as the organization or structure of a system where the system represents a collection of components that accomplish a specific function or set of functions. In other words, architecture is focused on organizing components to support specific functionality. This organization of functionality is often referred to as grouping components into areas of concern. The picture on this slide illustrates common application architecture with components grouped by different areas of concern. Special thanks to the comprehensive resources provided by Microsoft Developer Network.